Welcome back to another Algebra 1 Common Core exam. These are the solutions to the Algebra 1 August 2017 Regents exam. These, once again, are going to be the solutions. This time is going to be a longer video. These are parts 2 through 4. These are the short answer sections that do take a little bit of time to explain, but we're going to get through them, and we're going to get through them in a nice ethical way. That means don't freaking cheat off of this video, because these are the answers that everyone likes, because these are the long ones and I showed the most amount of work. So please do not take my answers, copy them, and put them on a piece of paper and call them your own. You need to try the problems by yourself in order to be successful. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. That will help me a lot, and I will forever be, or I will, how do I say that? I will forever be so grateful. That's how you say it. And make sure that you visit my website at www.nysmathregentsprep.com for more content in Algebra 1 and, of course, your future high school mathematical subjects. And once again, I use the TI-inspired calculator. That link can be found on my website as well. The link just goes right to Amazon. I have nothing to do with the calculator. I should really be getting paid from them, because I'm freaking advertising their calculator every Algebra 1 video that I make. But whatever. Here we go, number 25. Start off with a fairly easy question dealing with a whole bunch of numbers. A teacher wrote the following set of numbers on the board. Explain why a plus b is irrational, but b plus c is rational. Okay, so let's take a look at letter A. Letter A is equal to radical 20. Well, radical 20 we know is irrational. The reason why it's irrational is for the sole fact as if you take the square root of a prime number, that is going to be an irrational number. But you might be thinking, Trevor, what are you talking about? 20 is not a prime number, because you can multiply two numbers to get to 20. Well, let me explain a little bit further. The square root of 20 can be broken down into the square root of 4 and the square root of 5. The square root of 4 is 2, square root of 5. The square root of 5 is taking the square root of a prime number. So that's why it's irrational. 2.5, this is a rational number. And it's a rational number because it's a decimal that terminates. If it's a decimal that terminates, it is a rational number because it could be written as the ratio of two integers. And the square root of 225, if you don't know that, you can just type it into your calculator, but that is just the number 15. So basically, we need to explain ourselves why a plus b is irrational, but b plus c is rational. So let's begin. I'm going to say that a plus b is irrational because the square root, because the square root of 20, or in parentheses, 2 radical 5, is an, I should get rid of that, hold on a second, because radical 20 is an irrational number. Okay? The square root of 5 is an irrational number. Okay. Then we could say the sum of a rational, because 2.5 is rational, and an irrational number will result in a irrational number. And that's how you answer the first part of that question. That will get you a point. Then for the second part of the question, b plus c is rational. Well, yeah, 2.5 is rational, 15 is rational. If you add up two rational numbers, you get a rational result. So b plus c is rational because both numbers, which are indicated by b and c, can be expressed as the ratio, which is just dividing, the ratio of two integers. then you could just say the sum of two rational numbers results in a rational number. And you're done. That's how you do that question. Not too shabby. Not too bad of the question. Just devote those properties of numbers to memory and really understand them. And you'll do fine with those types of questions. Most of the time they're multiple choice, but sometimes they could pop up as a part 2. 26. Determine and state whether the sequence 1, 3, 9, 27 displays exponential behavior. Explain how you arrived at your decision. So how do we get from 1 to 3? Well, we could add by 2. But then the problem is from 3 to 9, we can't add by 2 to get this to get the number 5, because this is not linear, because it's not a constant rate of increase. So what's happening here, we take 1 to 3, we're multiplying by 3. 3 to 9, we're multiplying by 3. 9 to 27, we multiply by 3. This clearly is exponential behavior, because exponential is multiplication. So your answer can be written as this. This sequence displays or shows exponential behavior because the numbers, which in this case are 1, 3, 9, and 27, the numbers of the sequence are not increasing at a constant rate. Okay? The number 3 is being multiplied. To get to the next term. To the next term. And that's how you explain your answer. Again, not too bad of a question, just testing your knowledge on if you know the difference between linear and exponential growth. Exponential growth means multiplication. You could clearly see that right there. Okay, that's how you do number 26. Move on to number 27. Using the formula for the volume of a cone, express R in terms of V, H, and pi. So the volume formula of a cone is 1/3 pi r squared times the height. This is actually found in your reference sheet. I'm surprised that they even put this question on here, but it is what it is. You really see this formula in geometry, of course, but this is just algebra. They want you to express R in terms of the other letters and numbers. So we need to isolate R. So in order to do that, I'm actually going to get rid of this 1/3 first. I'm going to multiply by its reciprocal, which is 3/1. I'm going to multiply by 3/1. Those cancel. We get 3v equals pi r squared times the height. Now, we're just going to divide by pi and h. Divide by pi and h. So we get 3v over pi h is equal to r squared. Okay? Now, to solve for r, we're just going to take the square root to get r. So r is equal to plus minus the square root of 3v over pi h. So here's the thing, and if I'm not mistaken, when I checked the answer key for this on the Regents, they accepted r equals the square root of 3v over pi h. I'm pretty sure that's the answer. Now, this is why I'm a little concerned, just because of the sole fact that you get a plus minus at the very end, just because when you take the square root of a number, you actually get two results, plus minus. So if you could just bear with me real quick, I just want to double check the responses. This is number 27. Give me just 1 second. I'm sorry, I should have did this before. Okay. Yeah, so they actually gave credit for this, the square root of 3v over pi h, but I wonder if they gave you credit for the negative answer. Okay. So here's the thing. In geometry, when we're talking about geometry, the radius has to be a positive answer. So that's what I'm going with this answer. The positive square root of 3v over pi h. The radius of, and the answer key doesn't say it, but it has to be positive. The radius of a circle has to be positive just from your basic knowledge of Euclidean geometry. So I'm going with this answer, the square root of 3v over pi h, and I can say that with confidence, 100%. That is the answer to that question, not the negative part. Okay. Number 28. The graph below models the cost of renting video games and a membership plan A and plan B. Okay, fine. Explain why plan B is the better choice for Dylan if he only has $50 to spend on video games, including the membership fee. So let's go ahead and evaluate where the 50 is. So the 50 on the graph, I'm going to zoom it in here. The 50 on the graph is right here. Okay, this is $50. And remember that this is a cost function. So he only has $50 to spend. He can't go above 50. So if we go across, we get this intersection point, and we get this intersection point. Okay. This intersection point you see here is with plan A. This intersection point that you see here is with plan B. So follow this down, folks. Watch this. Plan A is down here. Plan B is down here. He's getting more from plan B, so he's getting his money's worth. He's getting more games, or the number of games. He's getting more games from plan B as opposed to plan A, because plan A has a higher membership cost. And I mean, look, eventually A will become the better one just because of its slope is less than B. But at this point in time, for his $50, plan B is the better option. So we're going to say for Dylan that plan B offers Dylan more video games at $50 compared to plan A. That's it. Nice. Easy peasy. Not too bad. Okay. Moving on to number 20. Nope. Follow-up question. Bobby wants to spend $65 on video games, including the membership fee. Which plan would he choose? Explain your answer. So we're going to $65 now. So we go to $65. This is kind of by fives, by the way. This is $65. Go across. Aha. They intersect right there. So your answer is either plan A or B. It doesn't matter. You're getting the exact same amount of video games if you have $65. So we're going to say that either plan, because both plans yield, that should be a I before E except after C, except in words that sound like neighbor and way. All right, plan yield the same amount of video games at the cost of $65. Okay, not too bad of a question. Could have been a lot worse. Moving on to number 29. Here we go. Samantha purchases a package of sugar cookies. Love sugar cookies during the holidays. The nutrition label states that each serving size of 3 cookies contains 160 calories. Samantha creates the graph below showing the number of cookies eaten and the number of calories consumed. Explain why it is appropriate for Samantha to draw a line through the points on the graph. I did not like this question because it's a stupid question. I didn't think it was I didn't see the point of this question. I really didn't. But basically what you had to say is that you could draw a perfect line passing through these points. And you know what? No, I kind of take that back, as in you could draw the line. And the reason why they want you to draw the line is who in the world stops at eating 3 cookies, 6 cookies, 9 cookies, 12 cookies? What if I want 2 cookies? What if I want 16 cookies? What if I want the whole sleeve? Sounds like most of us, right? What about 11 cookies? How about 10 and a half? I could split up an Oreo. I could split up a cookie. So, the whole thing here is they want you... What is going on here? They want you to just understand that if you draw the line, it includes every possible scenario of a cookie. What if you want 1 1/4? Obviously, you're not gonna have 1 1/4. But what if you want 1 1/4? So that's why the line has to be drawn. So your answer is going to be something like this. It is appropriate to draw a line through the points because there is a constant rate of change of 160/3. Now, if you were wondering, whoa, how did you get that answer? Simply just take the rise over the run. I chose the point 3, 160, and I just subtracted it from the point 0, 0. That is your slope. So, you could say this. In addition, and this is where the variation comes in with the cookies. In addition, the line can be used for any variation of cookie intake. Not just every 3 cookies. Okay? That is your answer. Pretty simple question. Not too bad. Just understand that you could have any variation, and it's a constant rate of change, so you could draw a line. Pretty simple. Oh, God. Okay. Nope. This question it irritated the crap out of him. It's so bad of a question, I want to slap the person who wrote it. Pardon my French. But let me explain why this is such a bad question. And you'll see at the very end why it's a bad question. A 2-inch long grasshopper can jump a horizontal distance of 40 inches. An athlete who is 5'9" wants to cover a distance of 1 mile by jumping. Not even running, by jumping. If this person could jump at the same ratio of body length to jump length as the grasshopper, determine to the nearest jump how many jumps it will take this athlete to jump 1 mile. Okay, here's the thing. I'm going to convert it to feet. No, to inches. Watch this. It says here in the problem, a 2-inch long grasshopper. So what I'm going to do is I'm going to take the 5'9" person, the athlete, and I'm going to convert the 5'9" to inches. Now it's not too bad of a conversion. 5'9" means 5 feet 9 inches. So you know it's 9 inches, but what is 5 feet in terms of inches? Well, you just take 5 feet times 12, because there's 12 inches in a foot. That gives you 60 inches. Add on the additional 9. This athlete is 69 inches. This is the height of the athlete. Okay? We got that down. Now, it says the ratio of body length to jump length. Body length to jump length. Okay. So, the grasshopper is 2 inches long. So, the body length of the grasshopper is 2 inches. Its jump length is 40 inches. We're going to set that equal to the body length of the athlete, which is 69 inches, over the jump length, which is x. We don't know how far the athlete jumps, so you have to set up a proportion to get this question right. Let's go ahead and cross multiply. 2 times x is 2x equals, 40 times 600. I'm just going to tell you that's 2,760. Divide by the 2 on both sides. X is equal to, when you plug that into your calculator, you get 1,380 inches. But, ladies and gentlemen, what does that mean? That means that the athlete can jump this distance. Okay? So now what we got to do is we got to convert it into miles, because it says how long will it take for the athlete to jump 1 mile. So we got to convert inches into feet, then feet into miles. Just because I don't know how many inches there are in miles. So I'm just going to take 1,380 inches and divide it by the 12 inches, and that gives us a total of 115 feet. Again, this is still the distance jumped. Okay? So what this is telling you is one jump. This athlete in one jump can jump 115 feet. Now do you see why this question is so stupid? Because who jumps 115 feet? You know, people could jump 3, 4, 5, 6, 7. I mean, look, if you're in gym class, you do a running position, and like you jump into the sand, like, and you measure, or like you jump on like a mat, and the teacher measures, oh, you jumped this distance, 115 feet. Are you kidding me? Really? No, stupid question. And the reason why I didn't like this question is students, you know, I tell everyone, oh yeah, think logically. Like if you jump 115 feet, it's probably not the right answer. But it's the right answer. It's the right answer. I don't understand. Now you see my fury as a future math teacher. I wonder if I will still have these videos up when I become a math teacher in 5 years? 4 years. 5 years? I think it's 4 years. So now we take 5,280 feet and divide it by the 115 to convert it into miles. Well, this puts it into miles, which will tell you the amount of jumps. When you do 5,280 feet divided by 115 feet, you get the answer 46. Ladies and gentlemen, this athlete can jump 46. Now, that's if you round it off, okay? Because it does say to the nearest jump. So if you do 5,280 feet in your calculator, 5,280 divided by 115 with a decimal point, 45.9 has to take him or her 46 jumps to complete this mile. Bogus question. Moving on. Number 31. Write the expression 5x plus 4x squared times 2x plus 7 minus 6x squared minus 9x as a polynomial in standard form. When it says in standard form, you bet your bottom dollar that they are asking you for descending power order. Okay? So, got to simplify this as much as possible, people. Distribute that 4x squared in. So we get 5x plus, now 4x squared times 2x gives you 8x to the third. 4x squared times 7 times 4 is 28. Carry along the x squared for the ride. Minus 6x squared minus 9x. We are going to combine like terms. The 5x with the negative 9x. The negative 6x squared with the, with the 28x squared and the 8x to the third just as it's by itself. So we get 8x to the third. 28x squared minus 6x squared gives you positive 22x squared. And 5x minus 9x gives you negative 4x. That, ladies and gentlemen, is your answer. 8x to the third plus 22x squared minus 4x. That is in standard form. Moving on to number 32, last of the part 2. Solve the equation x squared minus 6x equals 15 by completing the square. If you would please take my advice, know how to do completing the square, not just in this course, but you need to know it for geometry and algebra 2. And you do need to know it, maybe in calculus, but it's good to just have that skill for the next 3 years of your high school career, in math, I should say. So what we're going to do is we need to keep letters on one side, numbers on the other side. So for completing the square, letters on one side, numbers on the other. So in this case, we're good. Letters on this side, numbers on the other side. That's fine. Because remember, we need to now add in an extra term on both sides of the equation, because what you do to one side of the equation, you must do to the other. We need to insert these blank spaces in order to acquire a perfect square trinomial. To get what's inside of this blank space here, we need to use the formula b divided by 2 squared. That means you take half the middle term, which is negative 6, and you square it. So we take negative 6 divided by 2, square it. We get negative 3 squared, which is the number 9. So we have 9 and 9. Okay, so now we have this. So this is kind of the part where people are like, okay, what do we do now? You need to factor this by the AM method. Okay, so what adds to negative 6 and multiplies to give you positive 9? Well, that answer is just x minus 3. x minus 3. And that equals 24. We're going to combine the x minus 3 and x minus 3. We get x minus 3 squared is equal to 24. Okay? So now what we're going to do is, in order to keep going with this, is we need to take the square root. Okay? So we get x minus 3, because we just get rid of that square. X minus 3 is equal to plus minus the square root of 24. Now, the reason why it's plus minus here, not the plus minus in that volume question, is because a positive could, a number, I should say, could be positive or negative, not the radius of a circle. Okay? So, I'm going to add the 3 on both sides. And we get x is equal to 3 plus minus the square root of 24. That could be your answer, or I like it simplified. I like to simplify that radical. The square root of 24 can be simplified into the square root of 4 and the square root of 6. The square root of 4 is 2. Carry along the radical 6 for the ride. Your answer could also be 3 plus minus 2 radical 6. Either one of those answers is perfectly acceptable. Okay? And that's how you do that question. All right, moving on to number 33. These are the part 3s. I liked this question. It was a good question. Made your brain think. Here we go. Such a nerd, right? That I like questions. Whatever. Here we go. 33 says, Loretta and her family are going on vacation. Their destination is 610 miles from their home. Loretta is going to share some outside... No, sorry. Where am I reading outside from? Hold on a second. Loretta is going to share some driving with her dad. I don't know where I got outside from. Her average speed while driving is 55 miles per hour, and her dad's average speed is 65 miles an hour, just naturally because men drive faster. Yeah, that's true. The plan is for Loretta to drive for the first 4 hours of the trip, and her dad drive for the remainder of the trip. Determine the number of hours it will take for her family to reach their destination. So, here we go. This is the best way to do this question. So Loretta, so I'm going to put this as Loretta's driving, okay? They already tell us that she's driving 55 miles an hour and she's driving for 4 hours, okay? So we know that if we take her 55 miles per hour and we multiply it by 4 hours, we get, let's see, 55 times 4 is 220. So this means that she drove 220 miles. So 220 miles driven. Okay, you can just plug that into your calculator if you want to. 55 times 4. So she drove 220 miles. There's a total of 610 miles in this trip. So let's talk about the dad's driving. Okay? The dad's driving is a little different, because Loretta already drove 220 miles. So that means that if we take the 610 miles and subtract the 220 miles that was driven, there are a total of 390 miles left to drive. Okay? So dad is driving 390 miles. So we just take 390 miles and divide it by the 65 miles per hour. And we get, when we divide this, we get 6 hours. Okay? So the number of hours that it will take for their family to reach their destination is 4 hours, which is given to us, plus the 6 hours driven by her dad. Your answer is 10 hours. It takes 10 hours for them to drive. Okay? So that is the original plan. It will take the trip 10 hours to get there. But the problem is, after Loretta has been driving for 2 hours, she gets tired and asks her dad to take over. Determine to the nearest tenth of an hour how much time the family will save by having Loretta's dad drive for the remainder of the trip. So, we need to do pretty much the same thing as what we just did before, except now we're just changing that 4 to 2. So, let's go back and do this. Loretta's driving. So, things have changed on Loretta. She got tired. Okay? So, she drove, now it's 55 miles per hour times 2 hours. Okay? That will give you 110 miles driven. So, Loretta now drives 110 miles. So, now let's talk about the remainder of the trip. If we take 610 minus 110, there are now 500 miles left. Now let's calculate the dad's driving. So now he has a little bit more driving to do, but he drives faster. He's got a heavy foot. So we're going to take the 500 miles left and divide it by the 65 miles per hour. We get, when you type this into your calculator, we get 7.69 hours. Okay? So if we take the 7.69 and add it to the 2 hours, right? 7.69 added to the 2 hours, we get 9.69 hours. Okay? Now, how much time is saved? So to calculate the saved time, we take the 10 hours minus the 9 hours and 9.69 hours. That will result in 0.3 hours when you round it to the nearest tenth. So the whole family saves 0.3 hours, or just 0.3 hours in the trip. Honestly, that is not too long. I'm trying to think of, because 0.5 is 30 minutes. What is that? Between like 15 and 20, they only save like between 15 and 20 minutes. It's really not that much time, but it doesn't matter. That's the answer. 0.3 hours is what they save with her dad driving. Okay. That's number 33. Number 34, the heights in feet of former New York Knicks baseball players are listed below. Oh, they're going to be tall. Using the heights given, complete the frequency table. Okay, so basically what we're doing is we're taking all these numbers and we're plugging them into the frequency table. So, okay, I'm going to leave this up to you. You need to be very careful. You just need to go through each number and put a tally for each time you see. So, like, for example, 6.4 is in this box between 6.4 and 6.5. Then 6.5 is in the same box. 6.2 is in this box. So I'm just going to leave that up to you. I will tell you that these are the answers. There's 3 tally marks up here. 1, 2, 3, 4, 5 with that cross. 6, 7, 8, 9, 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 1, 2, 3. So this is 3. This is 10. This is 11, this is 0, this is 2, and this is 3. So that's your frequency table for this. Now on the following page, it says, based on the frequency table that you just created, draw and label a frequency histogram in the grid below. So let's just take our time with this. Let's just go through it slowly. So I'm going to count by ones, but really I'm counting by twos. I'm counting by ones on the graph. I'm just skipping the ones just to have more space. So 2, 4, 6, 8, 10, 12. So on this side, this is the frequency, or the amount of times it comes up. So that's the frequency. And on the bottom, this is going to be the intervals of heights. Okay? Now, you don't necessarily need to label your axes, but I highly suggest that you do. So I'm going to make this interval 6.0 to 6.1. I'm going to make this interval, all right, I'm going to change the color. 6.2 to 6.3. This interval, I'm going to make this 6.4 to 6.5. I'm going to make this interval 6.6 to 6.7. Make that interval 6.8 to 6.9. And last but not least, this is 7.0 to 7.1. So now all you got to do is you just got to graph those frequencies. So the blue interval has 3 frequencies. The 6.2 to 6.3 has a total of 10 frequencies. I should really make this a lot cleaner. Yeah, I'm going to use lines. Oh, this is so much better. Look at this. Yeah, I would use a ruler for this just because it just makes it more clean, right? Looks a lot better. Okay. Then we got, let's see, the green portion. The green portion is 11 people. 11 people. Then we got nothing over here. So the purple's good. The orange, there's 2 people. 2 people. Oops. 2 people. And for the last one, we have 3 people. 3 people. Now you just shade it in. with a pencil, pen, whatever you got to do. Shade it in. And that, ladies and gentlemen, is how you create a frequency table. Not too bad of a question. Now for the last part. Determine a state which interval contains the upper quartile and justify your response. So, excuse me, here's the thing. Upper quartile. Upper quartile means the third quartile. So, unfortunately, what they want you to do is they want you to input these frequencies into your calculator and get the frequency. No, sorry, to get the third quartile. So, I'm going to do that right now for you. So, go on your TI Inspire, go to the application lists and spreadsheets down here. I am going to type in up here, I'm going to type in interval. No, I can't do that. I actually need to type in all of the individual numbers. So, this is going to be a pain in the neck. All right, I need to type in all the numbers. So, what do I just call this? Heights. I'll call it heights. Okay. So, here we go. 6.4. I'm just reading this right from the chart. 6.5. 6.2. You could skip this if you want to. 6.9. This is so annoying. 7.1. And it sucks for you people because you actually have a calculator. Like, I'm using a computer. I have a keyboard. So, that's certainly a pain for you. 6.4. 7.0. 6.2. 6.3. 6.4. 6.4. 6.3. 6.5. 6.5, 6.1, 6.4, 6.5, 6.3. These are a lot of people. 7, 6, 6.8, 6.4. What's wrong with me? There we go. 6.2 and 6.2, 6.3. 6.3. Okay, so I have all that inputted into my calculator. Now what we're going to do is we're going to analyze this data. So menu, doc, add a calculator. Menu, statistics, stat calculations. We're working with one variable. We're working with the heights. And your upper quartile is 6.5. So your interval is the 6.5 interval. That's the interval where it lies, peoples. 6.4 to 6.5. The next one's 6.6. That's not the same thing as 6.5. So your answer is the upper quartile lies in the interval 6.4 to 6.5. Or the third interval shown in the histogram. Now it does say justify your response. Okay? So here's the deal. The justification's easy. The justification, you're literally copying your calculator page as shown here. So I'm actually just going to go ahead and copy it right now. It's going to get a little dark here. So bear with me. So, on your Regents, you are actually going to make this your justification. Keep resolution. This is all right. So this is your justification right here. That's it. And you could show that the third quartile, that the third quartile is 6.5 down there. Okay, that's how you do that question. 35. Solve the following system of inequalities graphically. All right, so they're telling you how to do it because you can't solve this algebraically because they're forcing you to do it graphically. As shown below, and label the solution S. Okay, so let's talk about this for a second. We need to put all these in y equals mx plus b form. Well, obviously these aren't equal signs, but we could treat them as equal signs. So for the first equation that I see, for the first inequality that I see, I'm going to move that 3x over. So we get 4y equals, keep on that equal sign, greater than negative 3x plus 20. divide by the 4, okay? We get y is greater than negative 3/4 x plus 5. Now, over here, where you're going to move that 18 to the right. So we get x plus 18 is less than 3y. Divide by 3, by everything. And we get 1/3 x plus 6 is less than y. Folks, I'm going to rewrite this a little differently just because the majority of you do not like that way of writing it. You like this way. Y is greater than 1/3 x plus 6. So what I'm doing is I'm switching everything. I'm switching the placement of the y. It's on the right-hand side. Now it's on the left. I changed the less sign to a greater than, and I moved the 1/3 x plus 6 from the left to the right-hand side. Okay? So these are your two inequalities. I'm going to erase this to give me some more room here. And we are going to graph these two equations. Y is greater than 1/3. Okay. All right. So y is greater than 1/3 x plus 6. So here we go. Here we go. I am going to describe what this is saying, okay? So we know that the slope is 1/3. The y-intercept is 0,6. It is a dotted line because it's just greater than, that it's not greater than or equal to. And it is shade above, okay? Over here, this one has a slope of negative 3/4. The y-intercept is 0,5. It is a dotted line. And it is shading above. Okay? So now what we're going to do is I am going to create an XY plot. So here we go. I'm going to draw in my X and Y axes, because you need to do that in order to get this question right, or else you have nowhere to go. Should this be up one? I love how they don't make these graphs symmetric. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. No, I'm just stupid. That's symmetric. Beautiful. Okay. So this is the x-axis. This is the y-axis. I'm going to graph my blue line first. So we get y is greater than 1/3 x plus 6. So 1, 2, 3, 4, 5, 6. Up 1 to the right 3. Up 1 to the right 3. Up 1 to the right 3. Now we go down 1 to the left 3. Down 1 to the left 3. Down 1 to the left 1, 2, 3. That is a dotted line, people. Dotted line. Okay. And it is shading above. Like that. Now for the next one, the y-intercept is 5. Down 3 to the right 4. Down 3 to the right 4. Up 3 to the left 4. Okay? And now we're just going to draw in that red line that's dotted, and we are shading above. And this, ladies and gentlemen, is your solution set right up here. You're done. Actually, you're not done. You could even label these lines as well, because it's always important. Label them as the original lines. So 3x plus 4y is greater than 20. And this is x is less than 3y minus 18. Now you're done. Okay. Honestly, if you get one of those questions, in all seriousness, you should not mess up on those. You should take them, get the points, and run with this question, because they're really not that bad. Now, we're done with this part. Now there's another part. It says here, is the point 37 in the solution set explain your answer? I guarantee that they're asking you, is the point 37 like the point of is this the point of intersection somewhere? Nope, sorry. The point 37 is right here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it's that point right there. Is that considered the solution set of this? No, because it lies on the dotted line. Any point that lies on the dotted line, even if they ask you for this point where it's the intersection point, it's not really intersecting, because again, they're both dotted lines. Anything that's on the dotted line does not work. So we're going to say no, or nope. Nope. Because the point does not satisfy the inequality x is less than 3y minus 18. And let me show you your proof. It's because you need to prove yourself because it says explain your answer. So this is actually explaining. You're going to take the 0.37, you're going to plug it into the bottom inequality. It does work for the top, obviously, but it doesn't work for the bottom. It needs to be a solution of both systems. So the proof is 3 less than 3 times 7 minus 18? Well, I just took that x value 3, plugged it in, took that y value 7, plugged it in. 3 is less than 21 minus 18. Well, 3 is not less than 3. That fails, so it's false. So that's why it doesn't work. Pretty simple stuff. Not too bad. All right, 36. An Air Force pilot is flying at a cruising altitude of 9,000 feet and is forced to eject from her aircraft. The function h of t equals negative 16t squared plus 128t plus 9,000 makes the height in feet of the pilot above the ground, where t is the time in seconds after she is ejected from her aircraft. Determine and state the vertex of h of t. Explain what the second coordinate of the vertex represents in the context of the problem. First of all, let's find the vertex. Unfortunately, folks, you need to do this question algebraically. Let me say that again. Algebraically. If you graph this and you state the vertex, you get it. Well, you get 1 point off. Okay? You need to know how to find the vertex algebraically. And it all boils down to the axis of symmetry. And if you don't know what I'm talking about, let me explain. If you have a quadratic, right? If you have a quadratic that looks something like this, and you're trying to find that vertex algebraically, you can't get that vertex unless you have an x value. And the axis of symmetry always passes through the vertex. Now, there's a formula for the axis of symmetry. It's negative b over 2a. So you could solve for x, take that value, then plug it back into the original function to solve for y. Let's go ahead and do that. So what I'm going to do is I'm going to solve for x first. Solve for x. The axis of symmetry formula is x is equal to negative b over 2a. So we're taking the information given in our equation and we're plugging in the corresponding numbers into our formula. So we have negative. Now the b value is 128. It's that middle number. Negative 128 divided by 2 times negative 16. This gives us negative 128 divided by negative 32. When you reduce this down, this gives you the number 4. So x is equal to 4 in this case. Okay? Now, we need to solve for y. Solve for y. So, all you need to do is you just take the 4, you plug it into h of t, and you get your y value. Remember, input-output stuff. If you input the 4, you get an output of some other number. So we get h of 4 is equal to negative 16 times 4 squared. Just plug it in wherever you see an x. Plus 128 times 4 plus 9,000. H of 4. When you plug this strand of numbers into your calculator, you get the answer 9,256 feet. Now, we got that. So determine, say, the vertex. So the vertex is the point 4, 9,256. Now, let's just say you did not, let me rewrite that a little bit neater. 4, 9,256. Now, let's just say you want to check yourself. Go ahead and graph this into your calculator. Now, I'm telling you right now, it's going to be so big, you're not going to see it. Or it might even look like a line. So negative 16 x squared. Make sure you plug in an x, not a t, because it won't work. Plus 128x plus 9,000. Okay, I told you can't see it. So I'm going to go menu, window zoom, zoom fit. Zoom fit, and we'll actually fit it for you. So the vertex or the turning point, so menu, analyze graph, it's actually the highest point on the graph, so it's the maximum point. So click, click. As you can see, it's the x value of 4. So therefore, we know that we got it right. And the vertex is 9,256. Hold on 1 second. Let me just make sure. Menu. I need to fix this a little bit. There we go. So 9,256. Good. So that's our vertex. now what we're going to do is, and it says explain the second coordinate of the vertex represents in the context of the problem. Well, x is the amount of seconds. Yeah, x is the amount of seconds. Y is the height of the aircraft, or in this case, she's ejecting. So this is the height of the pilot. So, we're gonna say this, our explanation. 4 seconds after ejecting from the aircraft, the pilot achieves a maximum height of 9,256 feet. Woohoo! Done. So that's how you do that part. Not too bad of a question, just you need to know how to solve it algebraically, and I highly recommend that you memorize the axis of symmetry formula, or better yet, you could go on my website, find the facts you must know cold for the algebra Regents, and that will help you as well, because that will be on there. Now, after the pilot was ejected, what is the maximum number of feet she was above the aircraft's cruising altitude? To justify your answer. So this is what they're basically asking you. They tell you in the problem that the cruising altitude of the aircraft is 9,000 feet. What your job is to do is to take the maximum height minus the cruise altitude. And that will give you the amount of height that she actually flown up. So 9,256 minus the 9,000. The pilot says, what is the maximum number of feet she was? So she was at a maximum feet of 256 feet. That's a high altitude, or that's a high number of feet. So when she was ejected at 9,000 feet, she flew up 256 feet, and then she was falling down to the ground, had a parachute, and landed safely. So that's what happened. Okay? And that's how you do that question. Then for number 37. Okay, this is the part 4. Nice. We're almost done. Okay, 37. This one was not tricky, but you had to read carefully. Zeke and his 6 friends are going to the baseball game. Their combined money that they have totals $28.50. At the game, hot dogs cost $1.25 each, hamburgers cost $2.50 each, and sodas cost 50 cents each. Each person buys 1 soda. They spend all of $28.50 on food and soda. Write an equation that can determine the number of hot dogs X and hamburgers Y Zeke and his friends can buy. So let's talk about this for a second. They tell you in the problem that each person buys a soda. Well, a soda costs 50 cents each. So let's go ahead and solve or evaluate how much money was spent on soda. Here's the tricky part. Zeke and his 6 friends. How many people are there? Not 6. There's 7 people. It's Zeke and his 6 friends. There's 7 people. So you're taking the 7 people and multiplying it by 50 cents. That will give you a total of $3.50. So Zeke and his friends, they spent $3.50 on soda. Now we need to find out how much money did they spend on hot dogs and hamburgers, X and Y. So it costs $1.25 for a hamburger. And it costs $2.50. No, I'm sorry. It costs $1.25 for a hot dog, $2.50 for a hamburger, and we're adding on the $3.50. This, all of it should equal $28.50. Now, why am I equaling it and not like making an inequality? Because they tell us in the problem that they spend all of it. So that's why it's going to be equaling that. Okay. So write an equation. That's it right there. You could write it as that, or I like to simplify it. In this simplified version, it's y equals negative 1/2 x plus 10. This is also correct, or the top way is also correct. You could just convert this garbage into the y equals form of a line. And you'll see right now why I did that. It says graph your equation on the grid below. Easy peasy. Now we just converted it to a negative 1/2 x plus 10. Let's go ahead and do it. So on the side here, Since this is the y-axis and they tell you that hamburgers is y, this is going to be the number of hamburgers. Okay? Down here, this is going to be the number of hot dogs. Okay? So, I'm just going to count by ones again. But I'm only writing the 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, over here, did I also count by 2s here? I think I did. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so I am going to graph negative 1/2 x plus 10. So it starts over here. Let me get a different purple. So it starts over here, and you're going down 1 to the right 2. But you got to be careful here, folks. Got to be careful. For every 1 hamburger, it goes over 2 hot dogs. So that's why I counted by ones here as well. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Keep on going. So you get down to the very end, down here, okay? That's your line, folks. All right, so this is the line of this graph. So here all the way down to here. Let me make those points a little bit bigger, and you'll see why in a moment. Okay, so this is the line that we have. Okay? That's it. Then it says, oh, and you can label too. Y equals negative 1/2 x plus 10. So for the second, or for the third part of this, it says determine how many different combinations, including those combinations containing 0, of hot dogs and hamburgers Zeke and his friends could buy, spending all $28.50. Explain your answer. So the key word here is combinations containing 0. Okay, meaning that everyone could buy a hot dog and no one could buy a hamburger, or everyone could buy a hamburger and no one buy a hot dog. How many combinations are there? Well, you just count the dots, people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 combinations. Some of you might be asking to yourself, well, how about the ones that are in between, Trevor? No. The problem is, let's just say you get 1 hot dog. That is 9.5 of a hamburger. There is no concession stand at a baseball field that will serve you 9.5 hamburgers. They will give you a full hamburger. So that's what they were testing you on. And I know it's kind of dumb. Well, actually, it's not that dumb. But just know that you just count up all the dots, and there's 11 combinations. And as you can see, this dot up here has all hamburgers, no hot dogs. This combination down here has all hot dogs, no hamburgers. So either you could get 10 hamburgers with no hot dogs, or you could get 20 hot dogs with no hamburgers, or you could get any of this combination in between. So to explain it, you're going to say 11 combinations. Now here's the explanation part. Because only $25, which is the result from $28.50 minus the $3.50 spent on soda. So they could only spend $25 on food. So only $25 can be spent on, here's a key, whole products of hot dogs and hamburgers. The line above, well, on your readings it's above, on this is the next, it's the previous slide. The line above shows 11 possible points where the combination would work. And that is how you do that final question. And that is the conclusion of this video. Make sure that you hit that subscribe button down below. hoping that you enjoyed this video. Consider becoming a patron on my Patreon page. I would greatly appreciate it. And make sure that you visit my website at www.nysmathregentsprep.com for more content at Algebra 1 and all of your future high school mathematical subjects. And I hope to see you soon.